Hello everyone. In this session, let us discuss about analytics for finance in detail. Nowadays, finance has become quite close to quant methods, machine learning tool, bioneural tools such as artificial neural network and genetic algorithm. The cardinal reason for this could be validation of financial theory in different parts of the globe and surely under different and diverse tax regimes. Also, the behavioral biases such as cognitive error, heuristic simplification, anchoring and herding make it even more difficult. So, the traditional methods of finance have slowly become insufficient and inadequate. Under that circumstances, Kahneman and Tversky's prospect theory and Richard Thaler's behavioral dimensions proved that time has come to address old issues in a new perspective. So, there came some data scientists, some physicists, some neural scientists, and in collaboration they created something which is one of the most relevant fields of study inside the domain of financial management, that is financial analytics. Robert Ingle and Clive Granger did remarkable work in the fields of financial analytics and econometrics with the maiden use of ARCH, that is autoregressive conditional heteroscedasticity. Boleslav continued that work and performed plenty of research for measuring and forecasting financial time series data, thus popularizing the wide use of GARCH, generalized autoregressive conditional heteroscedasticity. From industrial standpoint, Oracle Financial Analytics provides specific structured and detailed reporting at an optimum frequency to broad-based users from various levels. Senior management as well as frontline executives too receive prompt and apt information on revenue generation, skewness, spread out, depth of wallet share both geographically as well as according to specific verticals. In a crude way, we can say that financial analytics serves three functions. The first one is validation, the second one is identifying, and the last but not the least is predicting. These are the VIP principle in analytics for finance. Suppose some theory of finance can be relevant for the developed world with high financial literacy. Will that be applicable for a developing world with less financial literacy? There comes the need of validating the fact. Validating of facts will find the traces of behavioral biases too. For the emerging economies, behavioral finance is easy to understand but difficult to quantify and predict quantitatively. However, analytics solves that problem for us. A person who may default a mortgage payment may always not be having fund crunch or other financial obligations that are hidden. It is based on emotional call too. So, based on financial data alone, it became quite difficult to predict that whether the person will default or not could be quite an erroneous task. Again, financial crime prevention including anti-money laundering and terrorist financing could be prevented to some extent using analytics for finance. Behavioral pointers such as herding, anchoring or heuristic simplification is generally quite difficult to address. Heuristic simplification is in one's mind, where a complex situation is simplified automatically, ignoring many important as well as latent variables that can play a crucial role. Meta heuristic is not problem specific, rather it is generic simplification in nature. Stock markets are risky by nature is a typical meta heuristic phrase, whereas US markets behave erratic during Fed tapering is a heuristic statement. Financial analytics cuts through the clutter of the human behavioral cloud and reach the final destination quite seamlessly. Asset bubbles are pretty common nowadays, so are credit frauds. Financial institutions are getting challenged every day to get out of the mess. Most such asset bubbles were observed during the 2008 world credit crisis. Also, these bubbles come even before they are predicted at most occasions. identifying such events or at least likelihood of probable events in short while could lead to a financial preventive care. Another important concept where investment finance is stuck is to find an asset price in a long run. Valuation and price movement is a complex mechanism by its nature, having enormous number of direct and latent variables. Prediction on the forward path is always the key under such scenarios. Analysis and identification, though, hold the defensive part of the domain. Prediction holds the key for the future. Analytics for Finance course covers the in-depth understanding of the key quantitative methods of finance, financial econometrics along with statistical inference for financial applications. This course learning can be utilized in portfolio management, risk management, derivatives and proprietary trading. Many a useful software from industry as well as academic perspective will be used during the delivery of this curriculum. Some of the software will be SPSS, R, eViews, Num Excel, Excel Stat, GMDH Shell and Minitab. IBM predictive modeling modules are integrated in this course as well. Now, let us shift our focus to the holistic scenario. At most, a data scientist working in industry will have one or two of the luxuries listed above. What if scientists commonly used tens or thousands of different instruments for experiments and had no consensus on what combination of measurements will best describe the phenomena they aim to study? Let us say the instruments themselves are often hidden away in dark corners of different laboratories. The instruments may or may not have details on their output formats or documented protocols for getting their outputs in a good format for number crunching and plotting. In fact, these instruments may even produce corrupted data or delete data points seemingly at random. This essentially describes the scenario for a data scientist turned loose on a company's gigantic database filled with years of contacts, campaign results and customer or operations information often manually entered over time. Data for different projects or departments may be in completely different places and the company may not even be aware of all the data that they have. Beyond this, supplementing databases with public data can open a reservoir of even more expansive and varied data. As you can imagine, it is impossible to be sure how to handle all of this information in the best way or even if the information will be useful from the outset. For banks or large financial corporations, big data initiatives cardinally still revolve around improving customer interface intelligence, reducing various kinds of risks at different levels of process flow, and meeting regulatory objectives singularly or in multiple ways in case of multinational conglomerates. These are all activities large scale one financial firms continue to tackle and will do so for the defined and specific foreseeable future. Down market, we see mid scale and small scale firms, asset management, brokerages, advisors, regional banks, etc., able to adopt new data platforms, cloud and on-premise that are helping them to acclimatize with the mechanism complexities that their larger brethren should prepare against. This segment of the market, therefore, can move more rapidly on profitability, growth and strategic business projects that are targeted at more instant revenue contribution, as against the more long-term cost and compliance heavy priorities that larger financial corporations and banks are aiming on. Let's see the impact of big data. The vast proliferation of data and increasing technological complexities continue to transform the way industries operate and compete. Over the last 2 years, 90% of the data in the world has been created as a result of the creation of 2.5 quintillion bytes of data on a daily basis. Commonly referred to as big data, this rapid growth and storage creates opportunities for collection, processing and analysis of structured and unstructured data. Financial services in particular have widely adopted big data analytics to inform better investment decisions with consistent returns. In conjunction with big data, algorithmic trading uses vast historical data with complex mathematical models to maximize portfolio returns. The continued adoption of big data will inevitably transform the landscape of financial services. So, let us now talk about the 3 V's of big data. The 3 V's are fundamental to big data. They are volume, variety and velocity. Facing increasing competition, regulatory constraints and customer needs, financial institutions are seeking new ways to leverage technology to gain efficiency. Depending on the industry, companies can use certain aspects of big data to gain a competitive advantage. Velocity is the speed at which data must be stored and analyzed. The New York Stock Exchange captures 1 terabyte of information during each day. By 2016, there will be an estimated 18.9 billion network connected with roughly 2.5 connect per person on earth. Financial institutions can differentiate themselves from the competition by focusing on efficiently and quickly processing trades. Big data can be categorized as unstructured or structured data. Unstructured data is information that is unorganized and does not fall into a predetermined model. This includes data gathered from social media sources, which help institutions gather information on customer needs. Structured data consists of information already managed by the organization in relational databases and spreadsheets. As a result, the various forms of data must be actively managed in order to inform better business decisions. So, that was a brief overview about analytics for finance. Hope to see you soon for more of it. Thank you very much.